We're doing the truss section. Okay, so first thing to note, we're doing this section, and we're going to try to figure out zero force members here. So first thing to note over here, we have a zero truss member. So we have GIHI, clear as day. So these two are valid. Everything else, wrong, because wait, this has GI too, sorry. So we already eliminated one because we know those are zero H members. Over here, because this is zero over here, this is zero. I'm pretty sure GH should be zero too. Yeah, I'm pretty sure this is supposed to be a straight line. I don't know why it's not straight. So let's try GH for a second. Wait, this has to be a zero force member. I'm not trolling here. This has zero force. This has zero force. If this has a force, this thing is fudged. So far, we have GH, GI, and IH. Okay. So right now we are down to having it like this. Like this. Like this. Sorry. I am bad at this. So it's kind of like this. We have three forces over here. Oh, my mistake. Maybe we shouldn't draw it. I don't know. But we have 1, 2, 3 right now. And we so far have this kind of drawing where we have this, and this. EG must be 0. We already know it's gonna be D, honestly. But I'm trying to figure out everything else because this is actually really something I need to work everyone needs to work on. So this is A, C, E over here, and this is H, F, D, B, right? Now, according to this, this could be a 0 because this over here is like this is over here. So if I do this, this is moving this way. If it's moving this way, it's moving this way, which means it's going to slide downwards. Okay, so this must be a 0 shit, remember. Yeah. Right, AB. Another AB. Okay, so is that all of them? 1, 2, 3, 4. I think there's one more that I'm missing. And that would be no EG. I forgot EG. Oh, we got all of them. Yeah, yeah. So basically, this is all that's left of that. Pretty cool, right? Yeah. So yeah, we got that. Let's move on. Okay, we start over here. This is misleading. I don't like this. I don't know who draw this, but these are not to scale. What I mean by that is, come on, it should be like this, or it should be like this. Why is this so small? It confused the hell out of me because I didn't even think it was Newtons at first, because it was so disproportional. So we start with the zero members. So if we draw this out like this, we find there's a few zero members here. First of all, the first zero member, because the Newtons are going this way and that way, it's going to translate this way, translate this way. It's impossible for there to be a force here. So this is deleted, this is deleted. All right. What does that mean? We have 2 over here. Fun fact, these will be deleted too, because if you look over here, these must be forced, these must be forced, this must be forced if they aren't together, which means these two are null. In total, that means that the whole entire equation becomes a triangle with 3 big dots. And this is how we'll solve it. We'll do a 5,000 over here, 5,000, 50,000. We'll do a 25,000 over here. And you might think, wow, that really deletes a lot of the forces. Does that even make sense? Well, I mean, that's how it works. But if it doesn't make sense to you, here's my recommendation. Look a little bit close. Look at where the force is going. Like if this force is going down 2 ways, right? You might think there's 2 more options over here. But when this force over here hits over here, there's no force that pushes it back. Therefore, what would happen then is that it would move the whole object like this and won't be statically determinate or stable at all. With that said, we can now begin because now we know this is 30 cm or meters, just meters, and this is something like 660 meters or something. All right, now we know that's true. Now we know there's a force this way and a force this way. That is 2 forces at, and there's a force this way. So we can do multiple things. I would first look at this and say, what are we looking for? We're looking for AG. So I want as much information as I can possibly get from the point A possible. Now, we could do a moment on E, and that's what we'll do. To preserve the information on A. So this is A, this is E, this is C. Why will this be helpful? We actually delete one of the AXs, and we have AX and AY. We actually delete AX from the equation because there's no displacement in that direction. So summation of moment on E equals 0. We begin with that. And now we say over here, we have AY by 60, right? That is true. But what is it? It's a negative or positive. We use the right-hand rule, curl it up, and it's a negative. Now we begin go to C, and we go to C, and we see there's two of them, and both are actually going to be used. So we'll start with a plus, because we're going to do the 50,000 first. With the 50,000 one, you need to multiply it by this distance, which is 30, right? Next, we want to do the 25K. So 25K is a negative by the right-hand rule. So we can do minus 25000, curl up. The displacement is 30 equals 0. Well, we have everything. Good job. We got AY. AY is the force this way. That is not the force this way. So after we have AY, we need another equation to figure this out. Wait. Because, wait. I'm just realizing, what the hell am I? Well, yeah, obviously. So now, one trick is, hey, is AX equal to AG? Now, that's a good question. The answer is no, because we are looking at the exterior. We're not looking at the interior. What that means is that we have not cut this yet. We have not cut this yet. And if we cut this, we will see a force. Do I know the direction of force yet? We'll figure it out later. But what I'm genuinely saying is that we're doing the exterior first right now. We want the interior second. So wait your horses. It might look like we solved the problem. We did not. They're not aligned to the original length. So we can't really say anything yet. Okay? Because you might be, I genuinely think the real question is, can't you just do F equals 0 over here globally and understand that AX is basically equal to, the positive direction, and it's going to be plus 25000, so equals 0. So AX must indeed equal negative 25000. And that's correct. But that implies something wrong. That implies that is right in the ulterior sense, but interior sense we have to look in deeper. So let's first look at AY again and solve this thing with our trusty dandy calculator, which I have over here. Which let's do our calculations real quick. I'm gonna put my pencil over here, my earbuds over there and everything. Okay, let's do this division. So you can do this faster, but all you need to know is that there's already a negative over here, so we can just add all these up. You don't need to even think about how the minus is going to act. You're just going to do, well, to do what you got taught in high school, basically. But you never really mastered it because everyone makes a mistake on these things for like 20 years. And unless you're like one of those people that are just never made a mistake on these, which there is, I've seen it. So AY equal 12500. So AY equal 12, comma 500. Beautiful. We have both AX and AY, right? Okay. Glad you understand that. And it's negative. Okay. Well, that's interesting. Is that AX and AY? Yeah. Yeah. 125 and it's upwards. So let's now cut this. Oh, I didn't mean to erase that. I meant to do this. I meant to cut this, cut this. So what we have next is a force like this. Apparently it's like a force like this. And this is 25000 because I switched the direction. It's positive now. And it's 12, comma 5000. So I can already tell which one's kind of going to go into tension and which one's going to be a combination. But again, remember we cut this, so this is an internal showing, not an external showcase. Okay? Now here, we need to get the angle in between. The angle in between is this. The angle in between can be defined as a 10-10 triangle, which is 45 degrees. I don't need to even think about that. It's a 45-degree triangle. With that 45-degree, I can do another. Here's a very important part. We can do another showcase of a summation of these two things. So summation of fx equals 0 over here can be applied here again, which is beautiful, in my opinion. But if you don't find it beautiful, your choice, your choice, your choice. I won't put it against you. Summation of Fy equals 0, probably doing that first is actually more powerful because we can already see that there's only two forces that can do that. So we already know it's plus 1500 for the direction I'm going. And then it is plus F, what is this? AC equals 0, right? FAC equal negative Wait, it's not. That doesn't even make sense. FAC, what is it? Sine or cosine? It is sine of 45. So it's 12500 divided by sine 45, and it's a negative direction because of this goes that way. Yeah. So I already could tell that's supposed to be a negative there because right now it doesn't make any sense. But what that means is that I'll show you what that means soon. Negative 12500, and then we'll do a sine of 45 parentheses enter. And then we have that gives me like negative 1767.2. So this force is the opposite direction. So I can now write this over here, which direction is going. So I can erase this. So we assume this way cut, but it's actually going this way. Now this is a compression, not intention, compression. Yeah, compression. Unfortunately, that's a useless answer because we don't really need that. Okay, but the number is important because now we can claim over here that where is it clear? This is equal to negative 17677. Okay, that's pretty cool, right? Next, we can do, is it number important actually? I don't think so. We can do summation of fx equals 0. I'm just showing off the steps at this point, which is 25, comma 0, 0, 0. And it's a minus direction. And then we do plus fc. Wait, we don't even have to do that. We already have this. So we could just say this cosine 45 and we're done. I don't know why. I don't know why my brain didn't register that. We can do cosine 45. Okay. So when we did that, oh wait, we can't do that. I'm so stupid. Sorry, my mistake. These are two different forces. We can't do that. I am just thinking that doesn't even make sense. What is going on? Yeah, these are two different forces, so you have to do it this way. My apologies. I was right the first time. So we have to do negative 17677, and we have to do cosine of 45. Yes, that's two. And then we have to do plus f ag. And AG is there, and then we do a nothing to it because the angle is 0. So it's just going to be translated through like a beautiful, I don't know, blobberfish. I don't know what to call it. So now we add everything up here, 25000 plus parentheses negative 17677 parentheses multiplied by cosine 45 parentheses. This gives me like 37499. I see there's 37500, so it must be that. And you can kind of tell what's happening because I get positive because of the negative. If you move this all to the other side, it is positive. Therefore, this direction is correct. So what's happening here if with the cut is basically, if I were to show this off to you guys, which I will because I can, this is going this direction this way. This means tension, and we're good. So we'll see. I spent way too much time like explaining everything, but saying it out loud helps me learn. Whatever. I don't mind if I have to embarrass myself 600 times. Whatever. It's not like it's a big deal. Okay. Now again, this one's pretty simple in terms of like the zero members. There's no zero members, which is a good thing on the in my part in the part of the question being like a question that you can just simply do. This is 10. This is 30. I don't know what I'm saying. It's probably still a difficult question actually, but I'm not sure. I'm just saying things at this point. All right, it's not all right. Let's do B, D. That's what we're trying to figure out. Find a force member at B, C. All right, what do we do first? We can cut. We can definitely cut shit up and do things, but there's no point yet. Let us first look at the exterior. There's no need for me to find the zero members because there isn't any, first of all. And second of all, we're just looking at this now. Okay? Now, first thing to note is intuitively, we get a sense that AX, AY, and AC. Oh, no, sorry, CX, sorry. And then we get intuitively that AX must equal in some way C, this version over here, because if you do summation of FX, AX, and then it's actually plus CX, that means it's equal to 0, which means it's negative CX. I did the wrong direction, but it doesn't matter in the sense that it will, yeah. Okay. We got that coupleness, okay. So one equation was, I mean, we can make it easier for ourselves by changing direction on C, but we won't because I'm lazy and we're not about to do that thing. You know what? I will. Let's just change this direction because, you know, complexity on some certain thing is a good thing. Like diversifying the way you solve it is always a good thing in practice. Because when you do it in real life, you have like 16 different ways you have done it. in my opinion. I don't know if it's actually true. Summation of Fy. So we have Ay, which is a minus right now. Minus 5. I have a feeling this will also be a negative, which means my direction is my intuitive direction was terrifyingly wrong because this is minus 50,000, right? Newtons. So AY is going in the upward direction, which makes perfect sense to tell you the truth. Okay, so you can clearly see the problem. There's no way for me to figure out any of these AX, or do we need AX, Aldo? Do we need AX? I don't think. I mean, nice, I guess. There's intuitively it'd be nice, but I'm not sure if it's absolutely necessary. I think AX might be necessary. No, I'm trying to figure out if it's, we already figured out our we can figure out our AX, I guess. Yeah, that's fine. But you just have to do a moment and you can get that basically is what I'm saying. Is what I'm saying, yeah. Because oh yes, we kind of do. How we're gonna figure this out is not through this one because this one is not gonna help you because you won't be having enough information. What you're gonna do is cut over here, in my opinion, to figure things out. Yeah, that sounds about right. If you cut over there, you have an intuitive force on the AY side because AY is 50,000. We all know that is going to be a 50,000, and then we can do it the other way on pin X. So yeah, yeah. I think there's an easier way, although I just cannot seem to find it. But because we can find CY, this is possible. But is it possible doing it this way too? Over here, we need AX over here, and then we need a force dismember over here, which is, yeah, that's all we need, I guess. AX is, either way, we need AX. So we could have just done moment on A, and I think that's what I should have done. Moment of A equals 0. So if I do that, I get rid of two of them. And then we can say, okay, I think that's the faster way. Multiply by 10, right? Then that is in the negative direction. And then I could have done minus, right? And then the other one minus CX, right? And multiply by 30, right? Equals 0. And then CX equals, what is it? Negative, negative. So it's a negative 5, 0, 0, 0, 10, positive, and then negative 30, right? Is it in the negative direction? Am I correct about this? Both negative. Yeah. Um, so CX is actually in this direction, apparently. Ah, interesting. Which means like my first thought was right, and I was, yeah, that kind of makes sense because that would mean that this is the opposite direction then, because that from earlier FX we know it's the opposite direction, which means this is wrong and that is right. Oh well, more you know. Because there was a 50-50 chance I got the direction wrong, and apparently I did get the direction wrong. Anyway, it doesn't matter. It really doesn't matter because eventually with this we figured out it's 10. Let me just do the math real quick. So it's 50 with the another 0 multiplied by 10, and then we just divide by negative 30 for now, which is 166666667. So it is basically CX equal 16666.6 newtons. And right now it is negative, but if I change a sign like this to this way, I can change that to a positive really easily. And we can change this to a positive with that. So this is the right answer, 16666 newtons. Okay. With that said, we have this now. We can now cut it and we can expose the veins. So we can expose it like this. We can cut it like this. And we do CX over here. We know this is F, what is it? F CB. We know this is A. And we know A Y over here is this over here. Um, which if you cut it, basically what happens is this makes a force this way, this makes a force this way, right? And so on and so forth, how you do it, right? So although I will say that that might not be necessary to counter because we're only doing a summation on in the X direction and that's the Y direction, so we don't need to care for it. What I was saying about the cut over here is because it's external over here, and then this is negative, so it's actually this direction it should show up, right? Yeah, it should be. So what happens is that if I were to make this positive, because this is if you do this direction instead, you make a pull over here, but in turn you make a reaction force like this. So when you cut it, it's a reaction force this way, and there's a reaction force this way. So it's going to be this way direction. If I were to make it plus plus. Anyways, either way, you don't need that because you can add for at C pin. We could do a summation of fx basically. With that being said, what happens is basically equals 0 first of all, and then you do f of cb. We need this angle over here or this angle, I don't really care which one you choose. But if you chose that one, um, it'll be sine theta, right? Because it's this way. And then plus CX equals 0, right? Right? And then that would be, I need to get square root of 10 square plus 30 square. I don't know what that is. On second square root, 10 square plus 30 square root is about 31.66. So we could say CCB equals to 31.6, right? And what's on top? What's on top is 10. So let me just erase that real quick. 10. And then this is still in the positive direction, right? Plus cy. So FCB equals negative cx, sorry, not y. 31.6 divided by 10. So if I do 31.6 divided by 10, and then multiply it by whatever cx was, which is 16666.6. Oh, that's a little odd. And then that's negative FCB equal negative 50,266.456. So negative over here tells you a lot because it's this way, that means. And that's just to make it positive, do it this way, which is if you cut it is this way, which if you look at that over here, that direction, if you don't remember, is on wait, it should be in compression although. Did I make a mistake on the sign? Yeah, it's tension. Why is it? It should be compression although. Um, oh, I'm stupid. My apologies, my apologies. Because this is internal, remember, this is internal stuff. This is already the right direction. So if when I do this, it is going this because of the negative. So it is in compression. Uh, my brain just short-circuited a little bit, but it is in compression, so it is D. Determine the force in a member FH for the pin connecting thrust. What? All right, we're doing this problem over here, which is just um we're gonna look at this problem and realize that there's a joint over here. There's a normal joint over here. But guess what? It asks for a member of FE. So there's something called cutting that lets us basically delete stuff and not worry about this problematic situation over here. So we could just get rid of that, leaving us with basically this format. Well, luckily we don't even have that now. We have basically F, and the F has two ways of going that way, this way, and we have 1, 2, 3, 4. So we have this many of these. And that works out. I said we're cutting these three because they're easier. So it's like this, this, and then we create another force this way. Okay. All right. So now we have all the forces we need. This is going to be force EG. Let me get the eraser. EG. This is going to be force FG, and it's going to be force F, the one that we're looking for, H. And we, obviously it's not going to be 0 because there's another force over here that's going to counteract the top force. Excuse me. With that being said, we now have to solve this. Now, there's a few ways to solve this, but one way or another, a moment is definitely going to be needed because there's at least at minimum 3 unknowns and no way to solve all those 3 without moment. And we're going to do a moment on point A first, actually, because a moment on point A being 0 implies that we can get rid of almost everything. By that, I mean like the only thing in play there is this one, this one, this one, and this one. So in that sense, it's basically uh a free drive for a bunch of the more complicated unknowns, basically. So is 2000 parentheses 0.8 plus 1.6 plus 2.4 because there's 3 of them and 0.38 spacing plus FFG 2.4 equals 0. With that said, we can do f fg equal 1 divided by 2.4 negative, so it's a negative direction, 2000 parentheses 0.8 plus 1.6 plus 2.4, and then get your calculator out, and you can do the division yourself. Divide -1 divided by 2.4, 2000, 0.8 plus 0.1.6 plus 2.4 parentheses. Get that? I get FG equals -4,000. So we could delete all this complicated stuff because we got the information we wanted. We got FG equal -4,000 from the original direction we have over here. So there's no point in me doing anything more fancy than this. We stop over here. So with that said, there's still two unknowns, and over here you might be tempted to say, let's do summation. We can do summation and easily get this. That is true. Um, we can do summation, definitely. Um, but do I want to do summation right now? Is there easier way to get all the moments here? I think there might be forces here. I think there might actually be a few ways to do this. And I know it sounds crazy, but I think there is. Um, because if I do another moment over here, we can get FD and we be finished with the question. So we could do a moment on ME equals 0 and be finished with the question. Because we could do this distance over here, which is 0.8, and it's in the negative direction, right? Is it negative direction? Wait, did we actually accidentally do the wrong direction on the last time? I think we did. Oh yeah. Um, excuse me. Yeah, no, we did it right. Minus 0.8, I think, is appropriate. Yeah. Let me do this correctly, actually. Let me just first adjust this to make sure it's right. So we have this over here, which is E. Oh, wait. There's no way for, is there a way for me to easily get this distance from E? No, I don't think so. I need to get that distance, but I think you can't do it easily. So maybe I shouldn't do this way. Maybe I shouldn't. Okay, I know this way works, but we can also do a summation. And I think summation might be easier than this. I think just doing a summation of Fy equals 0 probably is the easier way. So we could do negative uh 2 3 -4 multiplied by 2000 first newtons, right? And then we can do uh negative Fg, which is plus 4,000 now, but it's the negative direction initially. And then we can do plus F. I think the other way you do two steps, but we need to, this way is actually longer, but we can do this and we can get this angle over here, which is basically doing, we need to get which angle over here actually is the question. Oh my God. Which is theta over here, which is sine of theta, which equals sine of theta is this way. So sine of theta negative. So it's definitely the negative direction. Okay, one of them is obviously not going the right direction, but it's negative, negative. And then we have, what is it? I'm flipping here. 2.5, and then with the square root this thing. So 2.5 square plus 2.4 square on plus 2.5 square equal is about 3.4 over here according to my math, which is 0.8 let me just do something real quick. 2.4, 2.4, 2.5. Okay. So that's it. And then that equals 8,000 minus, and then it's plus 4,000. This equals 0 minus FEG. 2.5, 3.4 equals 0. And then this is negative 4,000. So negative 4,000 multiplied by 3.4 divided by 3.5, 2.5, sorry, equal FEG, basically. So 4,000 multiplied by negative 3.4, 2.5 equals, so according to this, FEG equals negative 5,440. Okay, and if I remember correctly, the that is summation of Fx equals 0 can be used. So FEH plus FEG with once again 2.4 divided by 3.4. Was it 3.4? Yeah. 3.4 equals 0. So we can figure out FEG. Okay. So divided by 2.4 divided by 3.4. Was it 3.4? That sounds. Oh, it's 3.46. It's a little off, but who cares? Multiplied by negative 5,440 equals what? Oh, there's a syntax there. What was the syntax there? Uh, Multiplication. Okay, I get 3840, which is this. And it is in the positive direction because you go to the other side. So it's a positive direction, so it's in, so it is in tension, so therefore it is C. So it works. It's just a little complicated on the clean, not on the clean side, but you get the answer. Whew! Okay, now we're doing the these questions over here, and we're starting with this one. Okay, excuse me. What is the force on D and E? Oh, that should have 0. That's a 0 member, so that's A. That's a joke. Okay. Uh yeah, this is a joke. That's just a 0 member. Okay, next one. What's the reaction point at point A? Oh, we know that this force is going this way, and therefore it's reacting here. Um, this is normal. Normal. Is there any reason for these to react to this? This feels like isolated. I'm gonna say no. This is another zero force because why would this question is literally impossible without, yeah, I'm pretty sure. In this question, we do a global one, so we start with the global net force and moment force calculations. So with that said, we need to do a global M at A equals 0, the standard thing that we always do. So in this case, so we have to get this over here, and I'm thinking we start to getting this over here and this over here, which we can get by 5, and this is, if you don't know, is a similar triangle over here with the 7.5, and looks like it's 5, and this is a 10. X equals 7.5 divided by, no, that's wrong. It is 7.5 divided by 5, divided by 10, which is a half. So 7.5 multiplied by half. So this is a half of that. We got that finally. So we know the height of this is half of this. Okay. Um, yeah. And it's similar triangles, so you just have to match it. Similar triangles, match it, right? Anyways, with that said, we have figured that out. So this over here is the next thing we have to do is basically have this. So it's gonna be square root of 5 square plus whatever half this is, 7.5 divided by 2 square equal this length over here. So that is on square root of 5 square plus parentheses division of 7.5 divided by 2 parentheses square equal 6.25. So this over here is 6.25. So if I were to do a moment calculation, so I know this R, so we can just do moment of MA equals 0. We can do that now because we have R over here as 6.25. We have this as, I don't know, 3.25 or something. I don't think that's right. 7.5 divided by 2. 3.75, sorry, 7. No way. Now we do a moment calculation over here where we do it at A to get C. That's the purpose of this whole thing. So we do 3,000 over here multiplied by 6.25, and we do plus 3,000 again, and it's all positive. It should be all negative. And then it's going to be times 2, which is 12.5. And then it's going to be over here with the 5 multiplied by 3,000. Again, it's a negative, so over here it's like that. And then plus, and I'm going to choose the convention of this. So plus C, Y, parentheses 10. And then we're going to have another D, which is D, which is 3,000. So 15 parentheses 6,000, 3,000 negative again, equals 0. So plug that into my calculator. So 3,000, I could just add this all up because you move it to the other side. So CY equals 1 divided by 10, parentheses, everything here, but it's negative, so it's positive. So 300, 3,000, 6.25 plus 12.5 multiplied by 3,000 plus 5 multiplied by 5,000, no, 3,000. 3,000 plus 15 multiplied by 3,000 equal this number divided by 10 is this. So that would mean that we finally get some parity answer. So globally, I find that CY upward direction equals to 11625 newtons. Okay? So if that's the case, then we have to figure out AY if we want to, or we can simply just try to cut over here and figure out from here with the left side, because we got information about this. Therefore, we got all the outside information, and there's 3 unknowns over here. So theoretically, if you want to be cautious about your use this, you could figure out the moment of to figure out the force on EF, then use the summation rule to get the summation of it to this. But you need 2 angles here, and I kind of don't want to do that. I think um, it's easier if I have A involved, because I can look at this to say something interesting. If I look at this a little bit, I can tell that there's 3 unknowns here, right? But this is a solvable situation. And here's the thing about how it goes. If we have something like this, we can actually delete a few things over here at the moment. And then 3 forces here don't matter then when we do the actual calculations. Over here, we have something like this, right? In this case, there's 2 calculations over here, but there's 3 actually. And then this actually creates a little bit of confusion because there's more angles involved, in my opinion. So I think A would be easier, generally speaking. So we're going to go with A. So globally is first, although. So we have to look at global, not the internal yet. Globally, we have to do a force sum of x equals 0. So we know Cy, that's a positive direction. Now, here's the thing. There's multiple ways of doing this. I'm trying to figure out the easiest way. We begin over here with the force of x. Okay, so I think we need to actually just get the angle over here. Angle of theta, angle of theta, angle of theta. We know. No, I just realized this question is badly designed. Um, because I know for a fact this is 90 degrees, but there's no indication of it being 90. So, motherfucker, you have to guess. Um, Let's fix that because there's no way an FE question would do this to me in real life. They would indicate to me that all of these were right angles. So I don't have to confuse myself, right? They wouldn't just leave me to dry here, right? And having me guess these things. So let me just um because otherwise you're just guessing here. And that's gonna have to do it. That's gonna just have to do it for now. So those are the 90 degrees I just artificially made. Okay. With that, with that, sorry. With that being said, we can now begin. I just realized that half of these stuff don't have indications that this is parallel and this is down. We just assume it's 90 degrees down every time. It's just really funny to me. Okay, okay. Um, yeah, I don't know what to say to that. My brain just thought something really funny. Okay, so over here, we have to begin over here to get to this angle. And we know this angle actually has to, if you look at this, so if you look at this, oh, why is it not erasing? If you look at this angle over here real quick, I think you would recognize something. This is the classic angle where this data is that data. And then by looking at the comparison, this data is definitely this data. Therefore, we don't have to think anymore. We know what we're doing now. We know what that data is, that data. In that case, this sine theta is equivalent to saying the opposite. So 7.5 divided by square root of, let me just use my calculator, square root of 10, basically, square. Square root of 10, 10 square plus 7.5 square is 12.5. And then there's a cosine over here, theta, which is equivalent to saying 10 divided by 12.5. Now, with that said, now we can do this. So this force over here is theta. So this is actually cosine. So we could do 3 times the 3,000, parentheses, cosine um, of theta. So that is erase mark now because we can just change that to 10 over 12.5. And now it's a negative direction because there's a negative all of them. Now we can do, wait, are we doing y? Oh, sorry. Apparently I'm doing y because I am a moron and didn't read that we're doing x, even though I wrote it. Okay, so with that said, we could do plus c y, which is confirmed that way. And we could do minus 3,000 and then minus 3,000. So what does that accomplish? Well, we have ay. We can do plus ay there equals 0. So let's just figure out what ay is, and we're just deciding up is our what is the direction I chose. So um, let's do what we shall. Okay, parentheses, -3 multiplied by 3,000, and then we're going to do multiply by division, 10 divided by 12.5, and then it's going to be plus 11625 minus 6,000. Equals. Okay, I get it being 1575 newtons. The n looks like some kind of weird. Yeah, I don't know. Anyways, with that said, we have solved this portion of it. Now we can do summation on the fx equals 0. And with that said, we can do ax, and we're going to choose this direction as positive. Now we can do the sine of that, which will give you plus 3 times 3,000. And then this will be 7.5 divided by 12.5 parentheses. Wow, there's no other direction than that. Okay, equals 0. So ax equals whatever the negative version of that is. 3 multiplied by 3,000 multiplied by division, 7.5 divided by 12.5, which is ax this way equals negative 5400 newtons. Okay, we have done everything. Okay, so with that said, we can look over here and cut and get this form over here. This doesn't matter because we're going to just do over here the moment on E. The summation of moment on E must equal 0 as we discussed multiple times. The cut places must be 0. So with that being said, we can do, and we know this is 6.25 from last time. So 6.25, and it is in the positive direction multiplied by 3,000. Okay, this does nothing too because it's in line. Wow, is that it? Yeah. So that is another plus FBC multiplied by whatever that is. So 7.5 divided by 2 equals 0. FBC equals 2 divided by 7.5, and it's going to be parentheses negative 6.25 by 3,000. Uh, if I got that correct, then this is the answer. 7.5 multiplied by 6.225 multiplied by 3000. I get, did I do something wrong? I got something ridiculously, I got, I think I forgot two somewhere because I get, did I do something wrong? I did 5, 4, well, oh, sorry, I totally blew my mind. The A's, dude, dude, I'm so stupid sometimes. Don't forget about the A, X, A, Y, dude. Yeah, clearly they play. So AX, we played it like this. AX goes into the positive direction, and this is again 7.5 divided by 2. And then I need to, for the real test, I can't really fuck that up. That would be horrible. Minus 5 divided, multiplied by 8y. Okay, now, now let's do this. 6.25 multiplied by 3000. Okay, that's like that. Multiplied by negative 5400. Multiplied by division 7.5 divided by 2. Uh, addition here. So I get that. Minus 5 multiplied by 8y. So 1575. Okay. Multiplied by division, 2 multiplied by 7.5. Okay, I get AY equal 2500. Um, yeah. So that is D. I don't need to even think about it. We're moving on now. Here's a little trick here. Yeah, because of yeah, I think that's correct. Yeah, all right, we're good. Because I got negative and then I moved the other side. Yeah. All right, we got D. We're now moving on to 4, which is find the DE. DE is this, so we need to cut over here, definitely. But we will do that last. We need to, again, look at the global. And we need to look at the global first. So in here, we see that we have this. Okay, so if I'm going to cut it here, do you want to do it this way or this way is the question. And I'm looking for DE. Either way is good. I don't think there's a mistake on either side. I think the mistake I could make is just not going for it. So let's just do it. Let's just figure it out. And summation of MA equals 0. We know that 25000 multiplied by 20 is a negative direction. We're using the right hand rule always. And then we're doing this direction as positive. So plus 30 multiplied by GY equals 0. And I don't think there's any other case over here. And I need to like, yeah, there we go. GY equal negative 25000 multiplied by 20, right? It's a positive now, divided by 30. So 25000 multiplied by 20 equal that, divided by 30 equal, well, that seems like a large number. Let me double check that. Oh, wait. Notice something incredible here? AX also equals 0 because of how it works. So equivalently, no matter what you choose, they're the same, just by inspection. So actually, going this side is better because you see, you get rid of the 25000 newtons. Oh my God, I'm actually did the wrong path. Um, so I got 1/6 something. But actually, if I were to do this, I wouldn't do it this way. I would have done if I read for 5 more seconds, I think this way is better. With positive this one, so plus 25000. Let me start. Oh, it doesn't matter. And then plus so minus AY parentheses 30 equals 0. Both ways work, but I don't care which way I do because I'm not, oh, it doesn't really matter. So 25000 parentheses 10 divided by 30. I think that was the same. I'm not sure yet, but I think that was the same. Yeah, that's nearly the same. Okay. AY equal 83333.33. Just so you know, I think I got GY equal to 16666.33. 366. Yeah. So imagine that. Imagine that seriously. I chose this and this, and according to this, they will both, if I were to add these two up, because you can, they should equal, oh, might have made a mistake somewhere. Oops. Well, we'll figure that out later. Either way, this is the answer. Three zeros, multiply 10. Okay, here. And 8333. Yeah. I should have gotten, let me just check something. 25, 1, 2, 3, minus this. I should have got 58,000 for the G. I think somebody mistake. Whatever. AY AY equals 83333.33 newtons. Okay. And now here's the thing. I am actually gonna do this for fun, but I'm gonna do it the other way too, with the A method, because why not? Summation of MA equals 0. We were doing it earlier. Mostly because I feel like I made a mistake there. Multiply by 20, and it goes this way, so it is negative. Plus positive GY parentheses 30 equals 0, right? So in that case, I know that GY equal 1 divided by 30, right? And then it's going to be positive 25000 by 20. So division, I have to do 25000 multiplied by 20 divided by 30 equals 1 6. Okay, so according to this, GY equals 1 6 comma 666. Does that equal the right 8333? Oh yeah, it does. If you add these together, you get 25000. So that confirms everything is correct. Yay! Well, good job, me. Now we choose which path we take. Either one will get you the right answer. It doesn't really matter which one you choose. Now we obviously have to cut over here because if you look at it, it says find DE, and DE needs to be cut. And to cut these, you need to cut that. So in reality, I will tell you that this way, this cut over here is much easier. But I think we're going to do both ways just for funsies. Yeah, just for funsies. Because this only has AY. And we can do a moment on D first equals 0 to get C. Or because that's the only way we're going to get anything done. So we're going to get D over here, C and D. And with that said, we can actually start to add, or we could do, oh, we don't even have to do a moment actually. We can just do what we call summation of Fy, can't we? I think we can, because these two indicates the other side, and these two indicates this side. So what we can do is basically say F dE, right? And then we just need the angle over here, which is 5 and then 16 and 15. So I could do 15 square plus 5 square. So second square, 15 square plus 5 square equals about 15.8. So and then we can translate that to a cosine. Cosine data. Um, yeah, we'll figure out the angles later, actually. This is 15.811. Actually, we'll do it right now because we have the power to do it. 15.811, and we can just delete this one. And then we can do the 15 over here. With that said, we can next do what we call the directions. So right now, that's the negative direction, right? So we can do plus 83333 point bar, so it doesn't really matter, equals 0. So I can bar. I can do negative and a positive, so FDE equal 15.81 divided by 15 multiplied by 8333. So we can do 15.8113883 multiplied by 8333.33 divided by 15, which is 8784, and we know we can round up, so it's 8800. There's only one, and it's in tension because it's the right direction. So it is, in my theory, it is B. You guys can double check that, but I got B as the answer. Oh, sorry, not B. Sorry, C, C, C. Tension. Sorry, I read that question wrong. C. My mistake. I was about to say, oh, you didn't read the question correctly, huh? You got the right answer. Don't. I got 8800. Do not accidentally choose B, but dumb idiocy. Okay, so we need R1 and R2 here. Now, first of all, I can already see over here a bunch of zero member bars. Like this one's zero member, therefore this one's zero member. And ED might be a zero member because I can't see yourself having a force that way. Actually, no, it can't have a force. Yeah, that one I can just not there. But we can already get rid of like a bunch of them and make a triangle this way. Yeah, so we now have something like this uh, to replace it, basically. But I think that's probably the second part of the question. Yeah, that's definitely the second part of the question. So we won't be doing that right now. Yeah. So first of all, we'll do this portion. So first off, we're going to do what we call moments. We can actually create, this is 8 divided by 3 on both of them, I think. Okay, who the fuck made these questions, honestly? They keep on having mistakes everywhere. Well, one day figure it out. Anyways, yeah, okay, because other people are going to use this, I hope they figure out this is also the same, probably. Probably. So we'll do a moment over here first. A, so M Actually, let's see which one is the. All of them are different. So I just have to solve for one of them, and we're good. So obviously this is wrong because there's no way 25000 is not even. It's not symmetrical. So that's definitely wrong. I mean, that's like automatically just zero. Anyway, summation of a. So we can just go over here and say like, okay, 5000, and this is positive or negative. Multiplied by 8, and the other side is positive, plus R2 multiplied by 8 times 4 equals 0. That's 32, by the way. I was just being lazy. Equal 5000 multiplied by 8 and 32. Division 5000 multiplied by 8 divided by 32 equals 125. I think it's B, and we're not even going to double check this one, I don't think. Because why? You want to double check it, then you go ahead. Um, uh, yeah, I think I think that's the right answer, and we're not double checking that. Yeah. Hopefully that's the right answer. You want to double check it, you can double check yourself. I think that's right. Anyways, we're gonna move on now. And since we know from this R1 and R2, so from the knowledge of knowing R1 is 1250, we know R2 equals 3750 undeservedly. Wait, wait. Oh, it's D. Because I remember last time we checked this one, R2. R2 is 1, 2, so it's this one. My apologies. That didn't make sense. Uh, that was a tricky one. So it's 3750 newtons, and R2 equals 1250 newtons. You could check how it's not right because you would imagine this having more force, and that didn't make sense. So we could do R1 equal 3750 newtons, and R2 equal 1250 newtons over here. My apologies on that one. Okay, we can move on to the next question. This portion over here, which is basically getting the tension and everything, right? Compression tension. We're gonna do it by solving AC and BD. Now, where is AC? AC is this one. Let me erase all this first. This looks messy. AC, and then we're going to do BD. BD is this one. Okay, we're cutting those two. Okay, all right, we can do that. Um, First of all, we have to simplify this. I just realized I need to now do the lesson of. Let me grab my special pen. This is actually pretty hard to do, and you're not going to get it until you actually see someone else do it. So I'm going to get a pen over here. Now, first of all, if this is a force, this is a force, that's fine. But if this is a force, this is a force, and this has a force, we have a problem because this will move down over here. Down over here. You can see that over here. It will move down over here. And that's not allowed. So this must not be true. In return, then this is the same situation as earlier, and you can't really have a force going this way or that way, because it's static. You can't have things move. So this must have zero force too. Now, same logic over here. If this two must be true, then this has zero force. Now, you might be thinking, this is the same logic over here. No, this is a big no. The reason why it is not true is because of this over here. This changes everything. This allows for extra give on something, compression or tension on something. So in total, if I were to erase all this and now redraw everything, you would see this kind of development over here. You see this and this. And now you might be thinking, well, I think that's it. I think that is our simplified R2 diagram. And now we can figure out where to cut it. That'd be wonderful. And we actually think, I think we already know where we're going to cut it. We're going to cut it on these three axis points over here. So when we erase this, we're going to have something like this, this, ooh, that's a little off, this, and this. So actually, that's pretty bad. I think how to draw is probably just draw like this. So you have a point A and B, and you have a force this way, and a force downwards, and a force sideways. And then you're going to have a force this way and this way, which is going to be, oh, no, 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 not that way. We're going to have just one R1 over here. And now we have cut through BD. So let's just look at BD, BD. So BD and BD. And we'll see if it's tension or compression, and we'll figure everything out. I think they're all unique. AC, or we can look at AC. Either way, you can figure this out. I actually think AC is easier, so let's just look at AC first. Because if we do a moment on B equals 0, then we can say that there's two moments here, and two moments are different. So A R1, right, is equal to saying whatever this distance is, which we'll figure out by doing 8 divided by 3, parentheses squares, plus 8 squared equal what? So second square root, division, parentheses, 8 divided by 3, parentheses square, plus 8 square. That is 8.4. So that's 8.4. So this is 8.4327. So that's R1. Let me check this positive. Oh, wait. Sorry. I'm so fucking. What am I doing? Oh, shit. Like, what am I doing? It's right there. So it's 8. I'm so angry at myself on that one. That was a waste of time. Negative there. Okay. I don't know what I was doing there. And then we have, oh my God, positive 8 divided by 3 by AC, BAC. So it's going to be, how do I call it? FAC. Wow, I just wasted like a few minutes of my life on doing that. That was embarrassing. So equals 0. So FAC equals positive, so R1 8. And it's definitely not gonna be 0, right? Right? 3 divided by 8. Yeah, it's not gonna be 0. 3 multiplied by 3750 divided by divided by 8, multiplied by 8, divided by 8. It's 1275. That doesn't sound about right. So I did something wrong, or did I do something right? I got 110, so I think it might be just this tension. Is it the positive direction? So yes, that must be it. That makes it the answer choice A. I'm just gonna write that down. I can double check it later, but I think it's A. Yeah. Now, do you want to do the other part? No, I don't actually do that. Let's do this one next. The frame shown in the Constitution with pin connection members and supports, all applied forces are horizontal. What is the force in the diagonal term AB? Okay. Where's AB? Oh, AB, I see. So we're cutting over here. I don't think any of these are zero member things. So why do they keep on giving me zero member? I have no idea, but they keep on doing that. So what is the force of the diagonal member AB? Okay. Okay. Here's the thing. I don't think I need to do any like uh bigger picture global variables because I can cut. Or I can even cut over here. But that will give me nothing. I can't solve. That's indeterminate. Sorry. I cut over here. A two-sided without cutting for a minute. And I can get this over here. So this force, and this force. So this is going to be just 1,000 newtons. This is going to be 100 newtons, sorry. 100 newtons this way, this way. Now, with this 100 newtons, is this something bad? No. But what I'm trying to say is that will this force be anything? I'm trying to think. I don't think it should be anything because you have a force this. No. There's a way it can happen. So I actually need to go and assign a variable this way. We do a summation and MC equals 0. No, B. B is smarter. No, actually, wow. Wow. Oh, I didn't think of that. Oh wow. You can't do that. Um, wow. You can't do a moment, can you? That's not possible to it's not possible to no, I refuse. No, it's not possible to use a moment, huh? Oh, I I'm dumb. All you have to do is summation on fx equals 0. So it's 1,000 plus 100 plus 100, which equals 200, minus FBA, and it's going to be an angle, so it could be either cosine or sine. Let's just do cosine data for now, equals 0. So we have 200 over here, minus FBA, and then this cosine, I'm going to do data over here. So cosine is, oh, I need to do, wait, it's second square root of 15 square plus 20 square. That's 25 apparently. So bottom is 25, and the top is 20. Bottom is 20, whatever you can use, whatever knowledge you want. And then we can do FBA, and it's minus minus, so it's going to be equal to 25 divided by 20 multiplied by 200. The division 25 divided by 20 multiplied by 200 equals 250. And we have a 250 over here, so I'm just going to set that as true and move on because I'm pretty sure it's the answer. Okay. All right. We can now move on to this one, which is a piston thruster shown 10,000 applied load at LJK. Okay. I see what you mean. IJK, you mean. What is the force member of IJ? So we're cutting over here. We will definitely need global, right, for this one? No. Yes or no? First of all, um, yes, we will need global. Okay. So there's a few ways to do this question, but I'm thinking less members the better. So over here we see, okay, over here is a 4 5 a 3 4 5 triangle. So we all know what this is going to be. So it's going to be 3 4 5. So it's going to be if I do a sine of theta, then you know what it's going to be. It's going to be 3 over 5, and if it's a cosine, we know it's going to be a 4 over 5, and we all know that we're doing it this way. The theta is this way. Okay. With that said, we can get a moment here to get certain information out of this. Now, first of all, there is definitely a AX here. Now, I'm trying to figure out nothing, nothing. I already figured it out. We are gonna do a few things over here. We're gonna cut, and with the cut at IJ here, so it's gonna be this cut. And what is the force on member JJ? So, either we choose the left side, which has one more of these, so I think that's gonna be a no-go. Or we choose the left side, and I think we choose the left side, because that's one less member, and I think I can get rid of one of the moments by putting a moment directly over here. So AXY won't matter. AX won't matter. But before we do that, let's do the global variables first. Now, first of all, we all know what the fx will be equal to 0. So ax is this way we chose, which then is plus by I don't know, 10,000. We're only doing this because we're not really in the test, so why not do all of it? Sometimes sometimes I don't. 4 divided by 5 here. Okay, so this data, so that makes sense. And then this is going to be multiplied by 3 equals 0. So AX equals negative 10,000, 4 divided by 5 multiplied by 3. So that is negative 10,000 multiplied by 4 divided by 5 multiplied by 3 is equal to, over here, let me just erase this. Oh, um, let me just change this to red. And just because red is more clear on this paper. So I already know, and this direction is what we chose initially, and that's why we get that. Okay, so honestly, that information is hogwash. That information is probably not even needed. But still, it's a good thing to start. And we're going to do 0 because we need global first. And with global, we start with G, and we start at each of these nodes, leg nodes. We'll do 10, and we'll do in the, oh, do we really need it in both direction? Is there a way for us to solve this easier? Huh. Trying to think of a way for me to not do work. And I'm struggling to find ways. Maybe you can do like a movement transfer over here. I was thinking like this and doing some kind of graphical like cross product here, but I don't think that would work. Line of action is definitely not the way to go. With that said, I know what to do then. A painful thing I have to do, but I have to do nonetheless. It's basically saying 10,000, and then we know that the sine theta equals 3 over 5, and the cosine theta equals 4 over 5. So that means if I were to multiply this by 4 over 5, and then that would be our y direction. So generic force y, I guess. How do I write generic force? I'll just write this thing equals 1,000 multiplied by 4 divided by 5, enter, which equals 8. I think that's wrong. 10,000, sorry, 10,000. So it is definitely going to be in the y direction. So y is 8,000 from my 8,000. Okay. And then we'll do another one like this in the x direction, which will be by 3, and it will be 6,000. With that, we can actually figure this out pretty easily. So it's going to be 8,000 on the y direction. In the y direction, it is basically going to be like here, 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 this way. So it's going to matter about the x displacement this way. So in that sense, we have to care about this one, this one, this one, which is 10, and it's all positive. Plus 15, plus 20. Okay, now we're going to add the 6,000 next. And here is trick. It's all going to be the same. It's going to be 5. Okay, the question is it negative, positive? Yeah, see, it's clearly negative. So we minus that, and we do it this way. And then what next we do is basically reaction force over here. And as you know, this reaction force, this one over here with the AX cannot do anything yet. It cannot show itself as powerful because it's 0 displacement. So it's 30. So it's plus and minus 30. AY equal 0. So it's minus minus, so AY is equal to 1 divided by 30 parentheses 800, 8,000, parentheses 10 plus 15 plus 20, parentheses plus on a minus 6,000 multiplied by 5. And this should give me the right answer. So divided by 1, divided by 30, parentheses 8,000, parentheses 10 plus 15 plus 20, parentheses minus 6,000 multiplied by 5 equal 8. Am I correct about this? I think something's wrong here. Plus 6,000, so 12 plus 20. I get something weird. It looks like it's too big of a number for it to be actually correct. Um, no, I think oh wait, I forgot 3 here. There's a 3 multiplication here because there's 3 of them. No. Okay. Let me just double check my math real quick. 8,000. Wait. Oh, shit. They're flipped. This is 6,000, this is 800. That's why. So that means this is flipped. Oh, that's why everything was a little off with my numbers. Felt a little bit too weird. 6,800. Yep, that should be the right answer. So just flip those things to 8 and flip the other one to 5, and you should get a closer answer. So let me just do that real quick. Um, yeah, yeah. So it should be 1 divided by 30. Actually, let's just do the inside first. That's gonna be 6,000. We can just all right. 6,000 parentheses 10 plus 15 plus 20 equals this minus 3 multiplied by 8,000 multiplied by 5 equals that. Divided by 30 equals 5,000. So AY equal 5,000 newtons. With that said, we have AY now, so AY equal 5,000. We can now get rid of all this. Now we're going to cut over here. So what we're going to be left with is a force this way, and we're going to be cutting like this. And notice that we can use point C, so we can do a moment on C equals 0, basically. And this is a line of action, we can get rid of that, leaving us with AY, and that is in the negative direction, so that's negative 10. And then this is the top direction over here. That one is what we're looking for. So we're going to do plus Fij multiplied by 5. And that's also negative direction. Oh, we might be actually in the compressive zone. Compression equals 0. So in that case, we can do, we might be, I'm not sure if it is, Aij equal Ay 10 minus divided by 5. So it's definitely a very big number. Multiplied by 10, divided by 5, which gives you none of the answers. Okay, let me just double check this. Am I forgetting something? Ah, yes, I'm forgetting one of those. Yeah, that's getting none of the answers because I forgot. I need to like get myself into the condition of remembering that because my brain for some reason forgets the ulterior matters too. It probably is because I've been doing this for entire like forever and it's like getting late at night, but still it's kind of embarrassing. But not really, it's not embarrassing at all. I don't think it doesn't really matter. Anyway, with this said, we need to care about basically the 10,000, right? So there's 8,000, right? That goes in, and this is basically in line to it, so it doesn't matter. This thing doesn't matter. Only this matters. So the x matters, which is 8,000. So plus 8,000 is a negative. Multiplied by 5 equals 0. So let's do that again. Fij equals 1 divided by 5 negative, and whatever is here is positive. On the other side, 10 plus 8,000, 5. So 1 divided by 5, I mean, we'll divide by 5 last. Actually, we can do it together. It doesn't matter. So as long as you get the right answer, how you do it doesn't really matter, right? It does, actually. It makes the person that looks at this say, oh, lovely. And it actually does matter, but Because if you're the smartest man in the world, you can't explain your shit, then what the hell are you doing? There's no reason anyone will know what you did, and you'll die not no one knowing. Anyways, this is the answer, and this is gonna be negative. So negative means all right. So it's gonna be either tension or compression. Let's look over here. So in this point over here, this is right now assumed to be a tension, but because negative is actually in compression because it's pushing outwards. Compression. Because what we're doing is looking internally. So when we look at a string or rope, we always think of this as tension. But in reality, internally is being pulling each other. So you need to be careful about that. There's a difference between internal and exterior forces, and you just have to keep track of it. There's no written down like magical map to figure it out. It's just that you need to. I mean, there is a. It's not magical. It's just like looking at it and looking at the internal and looking at it. And you need to differentiate it. It's not really. I don't know how to describe it. Let's just move on. What is the re I mean, it's just understanding it basically. Sorry, I don't know why it took so long for me to say it. It's just understanding it. So over here we have this. I already know that a x must equal um 10,000, but in this direction. So if I weight it in this direction, is 10,000 newtons. I already know that, but that's not important here. But I can always write that over here if that's important because it's a 9-10 question. So it might be useful. It probably won't. And it's just by inspection at this point. We did like 20 questions on this, so you should probably know how to do inspection analysis a little bit. All right. So we're doing this. So honestly, we're doing a moment on A. I think we all agree that moment on A equals 0 was the right choice, and therefore we delete these two out of the map. I'm going a little bit. I'm skipping a little bit more steps now, but I should still actually not skip anything. 10, and it's gonna be 5, and it's minus 10,000 newtons multiplied by 10, and then this is all plus over here by 5, and it's gonna be multiplied by by equals 0. So you can tell now that by equals 1 divided by 5 parentheses. Negative is going to be positive there. It's going to be 10,000 multiplied by 5 minus 10,000 is going to be plus multiplied by 10. So moving to the other side. So it is again 1 divided by 5, parentheses 1, 2, 3, 4. Yeah. Counting the zeros on your calculator is also an important skill here because in reality over here, the most mistake you'll probably make is basically the calculator 0. I've done that before. It's no fun. Anyways, we should probably now get a certain answer here. Did I make a mistake here? I don't think I got any answers. Oh, it's a 9,000. And also another thing to note is look at the diagram correctly because it is gonna haunt you a little bit. This is actually 5,000. Here's the thing. You should be looking at those correctly. Anyways, with that said, we should get the answer soon. When I plug this back in, 1 divided by 5, multiplied by parentheses, 10, 1, 2, 3, multiplied by 5, plus 1, 1, 2, 3, multiplied by 10, parentheses, this and that. I get 20,000 equal by, which is D. And that probably is the right answer. I'm not double checking more. You can double check more if you want the test. Okay, next one. What is AF? AF is this one over here. What's the member force? So what's the force? What is the force in member AF? So AF is wait, I just deleted everything. Damn. This was like 20,000, right? I should probably write that By equal 20,000 newtons upwards. Um, it was upwards, right? I did get upwards. Okay, so that makes sense. And then what we're trying to figure out is a cut there that would help us immensely. Okay. Um, generally speaking, we already know what this is. This is 10,000. And because of that, we actually know what AY is because you can just subtract everything. So if I were to do 20,000 and do like minus 5,000 minus 10,000 and then minus 5,000, you wait, what? I was trying to say you could do summation of Y to figure that out, but something bugged up, I think, and I messed up somewhere. All right, but oh, wait. I think this is supposed to be a zero member then. But why? It's a good question. Usually there's a fast way to get it. I don't see the fast way. The reason I figured it out was basically 20,000, right? Plus 10,000 minus 10,000 minus 5,000 minus 5,000 equals 0. Therefore, there's no other force for here, so it must be A. But I don't, there must be a way to do it by inspection because this is usually by inspection. Um, yeah. Wow, I don't, let's try to figure that out. If I had a force here, then it would want to have a downward force. It could counteract by 1,000, but it has a force this way already, and this already has a focal point over here. So what problem does this cause? This is already converting to here. There must be a problem that this causes or something, because this is a normal force this way. Is this because of, yeah. I think it's a moment issue because these thing cause a right moment and left moment, and it must. Interesting. I got A either way. I mean, there's multiple ways to figure it out. And on my own time, I'm going to try to figure it out by inspection. I figured it out by plug and chug, which is cool and all. Okay, we're finally done with trusses. All right, I'm going to stop here.